Assalamualaikum. I'm New Atika Aziz and I will start this group presentation by introducing all the slides. For a starter, we will explain about differentiation, followed by explanation about related change. The next slide is the problem statement, then the problem conclusion, and finally the overall conclusion. Without further ado, I will begin the presentation with the first slide, which is the explanation about differentiation. Apart from integration, differentiation is one of the most important methods in calculus, where it is a process of finding a function that outputs the rate of change of one variable with respect to another variable, or most likely known as finding the derivative of a function. For instance, if x is a variable and y is another variable, then the rate of change of x with respect to y is given by dy dx. Here, we represent it as f prime x equal to dy dx. This is the general expression of a derivative of a function. Next, I will show one of the most common examples regarding the rate of change of a variable with respect to another variable, which is the rate of change of position with respect to time. So here, we have a car on a lane. Let's assume the car is moving, meaning the car's position keeps on changing. We can assign it a variable x. But then, since the car's position changes as time goes on, we can say that x is actually dependent on time, which is x equal to ft, where t is the representation for time. Hence, we will get the function dx per dt.
Next, related rates of change. Related rates of change are simply an application of the chain rule. In related rate problems, you will find the rate at which some quantity is changing by relating it to other quantities for which the rate of change is known. In the following examples, we repeatedly use the result dx over dy equal 1 over dy over dx.
To continue, my friends, before this, the example here is an upturned cone with semi-vertical angle 50 degrees is being filled with the water at a constant rate of 30 cm³ per second. When the depth of the water is 60 cm, find the rate at which, number 1, h the depth of the water is increasing, 2, r the radius of the surface of the water is increasing, and 3, s the area of the water surface is increasing. So the formula that we can use here is dx per dy equal to 1 per dy prime per dx. The solution here is the volume V of the water in the cone is given by V equal to 1 per 3 pi r cube equal to 1 per 3 pi h cube. We seek dh per dt. Now, V equal to 1 per 3 pi h cube, and therefore dV per dh equal to pi h square. dH per dt equal to dH per dV multiplied by dV per dt. So it's equal 1 per pi h square multiplied by 30. So the answer here we can get 30 per pi h square. When h equal to 60, we have dH per dt equal to 1 per 125 cm per second. We have seen that RT equal to ht. Thus, we When hash equal to 60, we have d hash per dt equal to 1 per 120 pi centimeter per second. We seek ds per dt. The area of the water surface is S equal to pi r squared. Therefore, ds per dt equal to ds per dr multiplied by dr per dt. So here we can get 2 pi r multiplied by 2t per pi r squared. So the answer we can get here is 60 per r. When hash equal to 60, and so ds per dt equal to 1 centimeter square per second.
In conclusion, differentiation plays a major role not only in calculus but also in our real life, as it able to help us solve from the complex scientific problems to our daily life problems. For examples, the rate of change of one variable with respect to another are used to determine the acceleration or speed, the maximum and minimum values, and much more. Here, we get to learn the bigger picture regarding differentiation that undeniably help us to understand the topic much more. Last but not least, we would like to show our biggest gratitude toward our lecturer, Dr. Siti Afika, for she had been assist us in this subject from the start until we eventually managed to grasp about calculus. Thank you very much.